Okay, continuing on worksheet 32904. This is the worksheet on molarity number 1. I just did number 3. Describe how you would make 0.5 liters of 2 molar solution of sugar. Okay, we're going to convert the grams, starting with 5 liters, liters to moles, moles to grams, 342 grams. Just went over that because I wasn't sure where it shut off. All right. Number 4, what volume in milliliters will 0.25 molar sodium hydroxide solution be needed to obtain 0.20 moles? Okay, so they gave you 3 variables. They want milliliters. They gave you molarity, which I took the M and always define it as moles per liter, so you can use that as a conversion factor. And then you're given 0.25 moles. Very simple problem. If I look at the mole map, they want me to go from moles, right in the center, to liters, which then I'll find milliliters. So it's just one step, mole to milliliter. And sometimes when it's too easy, you think it's hard, but it's not. Okay. What volume in milliliters? Milliliters goes to the right. Solution. SOLN means solution. The left, we're starting with 0.20 moles of sodium hydroxide. That's my solute. Basically one step to get the volume. Start with moles on the top, so you put moles on the bottom because you want that unit to cancel. I'm only ever going to use this 0.2 once, so I'm done with that, 0.2. I want to know how many milliliters. I'm done with that. Well, I want to go from a mole, and I have to go to a liter. So 0.25 moles equals 1 liter. Okay, so I'm just, now I got liters and I need to go to milliliters, and that's why I put this gold down there. So now liters goes to the bottom because you want liters to cancel out. And I want to go to milliliters. This is a conversion that you should know. When it's a unit conversion, you should know that 1,000 milliliters equals 1 liter. All dimensional analysis. 0.2 moles of NaOH is equal to 800 milliliters of solution. To get that number, I take 0.2. When I multiply it by my conversion factor, you don't have to hit times 1. You can just hit divided by 0.25. If it's on the bottom, you hit divided. Times 1,000, answer is 800. Okay, so if you pour out 800 milliliters of this solution, there's 0.20 moles in it. Okay, the concentration for every 1 liter, there's 0.25 moles in it. These two numbers equal each other, so every time you're multiplying it by conversion factor, it's really multiplying it by 1. You're not changing the value. 1,000 milliliters equals 1 liter. So every time you multiply it by a conversion factor, you're multiplying it by 1. And that's why you can say that 0.2 equals 800. Okay. We've done the problems where we're just going back and forth from grams to liters and liters to grams. Number 5 is a different, that's your third type of problem. It's a concentration problem. It says, what is the concentration in moles per liter, which is molarity? Okay. I can create a list on the left. It's a good way to do the problem. They want to know the concentration, so you want to know the number of moles per liters. Okay, the solution is KOH. So what I want to do is I want to define my molar mass is moles of KOH per liter of solution. Okay. What do they give you to work with? They give you 10.4 grams of KOH, and they give me 225 milliliters of solution. Now, this is not directly dimensional analysis. I'd like to say it's kind of like plug and chug. With my definition of molar mass, I see that I need to find moles of KOH. So to get to moles, I can start with grams. 10.4 grams. Grams can be always converted to moles. Okay, so I'm going to do a short dimensional analysis problem where I convert grams of KOH to moles. Whenever you have a conversion factor between a gram and a mole, that's your molar mass. Okay, KOH. K equals 39.1 grams per mole. O equals 16.0 grams per mole. And an H, each one would be just 1, would equal 1.0. These all total up to 56.1 grams per mole. I get these numbers off my periodic table. That's where I always get molar mass. So when I look at this number, I always put units on it, grams per mole, because to me that means 56.1 grams is equal to 1 mole. So now I'm going to just find the calculator and divide that. So I got 10.4 divided by 56.1. I get 0.185. 3 significant figures. Now when I look at what I'm trying to find, molarity, that's equal to 0.185 moles. Now I need to find the liters. And I'll do a second short step. I've defined my molarity. I've used the 10.4 grams. Now I know that I have 225 milliliters. Well, I need the unit in liters. So I can go milliliters to liters, 1,000 to 1. So that's divided equal to 225 liters. Now, you take your calculator because you want to divide this and get just one answer. 0.185 divided by 0.225 equals, this is not molar mass. This is just molarity. M. So M equals 0.8424. Now your units are moles per liters, but I can rewrite that as go backwards and just say it's 0.824 big M of KOH. And I found my concentration. Always find concentration by defining concentration. Okay. This problem, grams, liters. So this is the first two, just going from liters to grams. How many grams of HCl are needed to make 10.5 liters of solution? Now, the big M, I'm going to always define it. 1.5, that's a conversion factor where I convert moles to 1 liter. And that's HCl. So these are that's my list of my 3 starting points. And this is how you make a problem simpler. Okay, applying dimensional analysis, my goal is to get the grams of HCl. So I put that to the left. I'm starting with 10.5 liters. Okay, using dimensional analysis, I want to go from a liter to a mole. Using dimensional analysis, I want to go from a mole to a gram. This is the molarity, 0.15. 1.5 moles equals 1 liter. Now, for gases, we could have used 22.4 liters per moles, but that's a gas. Okay, so we're doing solutions, which is totally different than gases. We cannot use 22.4. We can't use PV equals nRT because we're talking about aqueous solutions, not gases. Okay, it is possible to actually find the molarity of the gas, but that's where we use our gas laws. The molar mass for HCl is 1.0 for H, 35.5 for chlorine, so 36.5 grams per mole times 36.5 grams per mole in your calculator. 10.5 times 1.5 times 36.5 equals 575 grams. And that's what we got. Let's flip over the bottom. We got a few more problems. Okay. Number 7 gives us our fourth type of problem. Okay. This is a says must be diluted. So this is a dilution problem. Now, when I create my list, it's asking me for a volume. So volume equals question mark milliliters. Okay, of 5 molar solution. So molarity equals 5 molar. Now, in this case, I'm not going to define molarity because I see that they give me a second molarity. Okay, and the second molarity is 0.2. Now that solution is dilute. It's less concentrated. This one's concentrated. In a dilution problem, we're taking a concentrated solution and adding water to it to dilute it, to make it less concentrated. And then the second volume is here. This is volume 2, this is molarity 2. The biggest thing you have to do in these problems is make sure you pair up the volumes and the molarities correctly. You don't want to pair this volume with that molarity. The key word is where it says of a. Of a links those two together. Okay, volume 2 equals 500 milliliters. And then this would be volume 1, this would be molarity 1, this would be molarity 2. When you get a dilution problem, it's a very simple solution. M1 times V1 equals M2 times V2. That looks like a gas law, Boyle's law, where we had P1 V1 equals P2 V2. Okay, we're going to solve for V1. So algebraically, V1 equals M2 V2 over V1. Just plug my numbers in now. I have 0.2 molar. 500 is the volume. That's V2. V1 was, yeah, I kind of screwed that up. This should be M1. Okay. Solving for V1, you would divide both sides by M1 from the beginning equation. So that's divided by 5 molar. The molarities end up canceling out, and that's why I really don't have to worry about defining the unit of molarity, because it's always going to end up canceling out. The answer is equal to 20 milliliters, and that's V1, 20. Okay, these are really easy when you get them. What we like to say is they're like fresh fish. They're very easy. If 500 milliliters, volume equals 500 milliliters, always create a list. 6 molar is my molarity, 6.0. Okay, and then you got a second molarity, M2, M1. Second molarity is 0.1 molar. And what will be the final volume? So I want to know what V2 is. And if it gives you milliliters, you're going to get milliliters. Okay, and this is V1. So I'll define M1 V1 equals M2 V2. It's get to be very easy. Solving for V2, I'll divide both sides by M2. So V2 equals M1 times V1 divided by V2. So if I now just plug in my numbers, 6.0 M, that's M1, 500 milliliters. So 6 times 500 is 3,000. Okay, and we're going to divide that by 0.1, big M. The big M's cancel out. It's a lot of liquid. You would need 3,000 divided by 0.1, you would need 30,000 milliliters. That's what you would get of solution. So from that, if you want to make that concentration you can make 30,000 milliliters, which comes to 30 liters. But look at that as a whole. Another one, very easy, same thing. Create a list. V equals 800. Molarity equals 2 molars. I can, as soon as I see that I have two different molarities, I know that I'm using M1 V1 equals M2 V2. The final volume is V2, the initial volume is V1. The big thing on these is that there's no reaction. All I'm doing is, there's the word diluted, or diluted. If this is a reaction, I have to actually use a different style. I have to start defining my molarities. But I'm only talking about one chemical, so it's just dilutions that we're looking at. 1, 1. The M2 is 0.4. And the V2 is what we want to find out, milliliters. So I'm going to solve for V2, dividing by both sides by M2. Same problem as last. I just plug my numbers in. 2 molar times 800. That'd be 1600. I'll show you a little trick. After I do these, I'll show you a little trick that'll be useful later on. I'll divide this by 0.4 m. The molarities cancel out. So 1600 divided by 0.4 is 4,000 milliliters. If I converted that to liters, it would be 4 liters of solution. Okay, number 10. When I look at number 10, it asks me for the concentration, but it doesn't give me another concentration. It does give me an answer, but that's not the second one. So this is not an M1, V1, M2, V2 problem. It does ask me what's the concentration, so this is a molarity problem in M. It's not converting from grams to milliliters, I know both. Okay, so the secret to doing a concentration problem is to define your molarity. Big M equals the number of moles of NaCl divided by the liters of solution. Okay? Now, I look at my two starting points. I could create a list. Big M equals question mark moles per question mark liters. And I'm given 2.5 grams NaCl. And I'm given 500 milliliters of solution. Okay. So to solve this problem, I've defined what I want. I can take the grams and convert them to the moles, so I want to go from a gram to a mole. 2.5 grams of NaCl to a mole, grams to moles. 23 plus 36.5 is 58.5 grams per mole is the molar mass of NaCl. I did that in my head. You'd probably want to show it on your work. So 2.5 divided by 58.5, 0.0427, which I would round off to 0.043. Because I only have two sig figs, 2.5. Okay, so I plug that in to the number of moles of NaCl. I know that you got 0.043. Now I need to find the liters of solution. So I would take the 500. I would use dimensional analysis, go from a milliliter to a liter, and there's 1,000 to 1. So the answer is that it's 0.500 liters. So I divide for my answer. 0.043 divided by 500 equals, the molarity equals 0.085. Now I could say moles per liter. Now I can just define that as 0.085, big M for shorthand. So if I was making this a bottle of this for class, I would label my bottle. And if you see other bottles in class, you'll see them all labeled with big M's because they're all standardized for concentration. All right, and that is how you do this worksheet. Now I'm going to post the second worksheet. Very similar, different numbers, but if you look at this one, you should be able to get all your answers for number 2 worksheet.